Yo, what's up everyone? Patrick here. Welcome back. Moving on to the next question. We have to solve this system of equations here by substitution, particularly. So we got 2x equals 3y plus 10, and then we got 3x minus 4y equals 5. So this one kind of sucks because notice that there's no variables that are by themselves, that are isolated. They all have a leading coefficient other than 1 in front of them. We got 2, 3, 3, and 4. That's the first thing I look for. Is there any x or y by itself when I'm doing substitution? Over here there's not, so what we're going to have to do is maybe deal with some fractions. So next thing I check for is, can I divide any of the leading coefficients throughout and end up with whole numbers? And notice here, if I divide everything by 2, the 10 divided by 2 would be a 5, but the 3 divided by 2, that would be a fraction. If I divide everything by 3, I'll have fractions. Over here, if I divide everything by 3, I'll have fractions. If I divide everything by 4, I'll have fractions. So no matter what, we're going to have to deal with fractions. So what I'm going to do is I'm actually going to isolate for this x here. Notice how it's almost already isolated, right? We have this x expression by itself on the left side. So if I take that, let's rewrite it over here. If I divide everything by 2, I'll have x equals 3 over 2y plus 5. And then what I'm going to do is I'm going to take this expression for the x and plug it into this x. Right? This is the first equation. This is the second. So this is still the first. Taking that, going to plug it into the second. So we would have 3 times, and then I'm going to plug all of that in. 3 over 2y plus 5 minus 4y equals 5. And now notice that we have an equation all in terms of y. So we'll have 3 times 3 over 2, which is like 3 over 1 times 3 over 2, which would give us what? 9 over 2y? Plus 3 times 5 is 15. We got minus 4y equals 5. So what I'm going to do here, I'm going to keep all the y's on one side, and then I'm going to bring the 15 over. So we'll have 5 minus 15, which would give us negative 10. Now this 4y, I'm actually going to change it, this is like 4 over 1, change it to have a common denominator. So the 4 over 1 we could change to be 8 over 2. Right, so we'll have 9 over 2y minus 8 over 2y, which would give us 1 over 2y. And then we got a negative 10 over here. And then basically y is going to be negative 10 divided by 1 over 2. Like that. All right, divide both sides by 1 over 2 to get the y by itself. And this is like negative 10 over 1 divided by 1 over 2, which is like negative 10 over 1 times 2 over 1, right? We could flip that fraction and then multiply it. And then this is like negative 10 times 2, which is negative 20. So the y value is negative 20. And then what we could do, we could take that y value, plug it into either equation, and solve for x. We actually have x already isolated here, so I'm going to plug it in here. Now, usually you want to take this, plug it into one of the equations, and then work from there in case you made a mistake. But I'm pretty confident that this is correct. So what I'm going to do is x equals 3 over 2 times negative 20 plus 5. So we'll have negative 30 plus 5. So we'll have negative 25. And so these two lines, they basically intersect at the point negative 25, negative 20. That's the final answer. And then you could also check it. So what you can do is you could plug it in. If you ever get time on your test, you could plug it into each of these and make sure that the left side equals the right side. So notice for this one, if we plug in x, negative 25, 2 times negative 25 is negative 50. Then we'll have 3 times negative 20, which is negative 60, plus 10 does give us negative 50. So left side equals right side here. And then if we check it with this one, we'll have 3 times negative 25, which is negative 75, minus 4 times negative 20, which would give us negative 80. And notice negative, negative, that would be a positive. Negative 75 plus 80 does indeed give us positive 5. All right, so checked it here, we could be pretty confident that that is the correct